Welcome to the WANdisco Fusion lesson on performance tuning. The topics are as follows: performance considerations, hardware sizing guidelines, server performance tuning, memory considerations, small cluster problems, consistency check and repair performance, OS and network tuning, and best practices. For performance considerations, the number one consideration is the number of transactions you're going to replicate. Remember that each file system operation is a transaction that Fusion needs to coordinate. The more of these, the more CPU usage, the more heap usage is going to be required. The Fusion kernel is roughly capable of handling 1,000 of these per second, and that's with low round trip times. The volume of data you're going to replicate is also important, and the most important consideration here is probably your WAN. It's at the mercy of the bandwidth between Fusion servers. The question to ask is, will it keep up when asked to replicate the local ingest rates you need? This can fall behind for long periods of time. Fusion can handle that, but not forever. And the next and last performance consideration, broad consideration, is the resources available. Latency has an impact on the coordination rate when agreements are being made. WAN throughput is the ultimate limit of what data we could push. So that dovetails in with the volume of data to replicate. In today's world, usually CPU or memory bound issues aren't prevalent on modern hardware. But if you're using shared resources in your environment, additional thought is needed. Hardware sizing guidelines can be categorized as follow. There's low-end scaleds, large-end scaleds, and what we call billion objects and petabyte scale, very large scale deployments. For the low end, this could be POCs or just an internal testing environment to see how Fusion works. The 4 CPU, 32 gig of RAM is acceptable. And in today's world, I probably wouldn't even recommend that for a POC. I would probably go to the large scale, which is 8 CPU, 64 gig to 128 gig of RAM. That's over 100 terabytes per year replication. And that's just to be on the safe side. And a lot of customers and a lot of prospects start with implementations of this size for the Fusion servers. The billion object petabyte scale projects, they do require 16 CPUs or more and 126 gig to 256 gig of RAM. I would say even the 256 gig of RAM is probably a good starting point for these. But as you get more experience with Fusion and implementations and POCs, you'll have a better idea of what size to use for your particular project at hand. Server performance tuning. Thread management changes can be made to the etc WANdisco Fusion Server Applications property file. A good guide for this is in the hashtag fine-tuning directory, as you see on the screen. This document can be used as a guide to tune the server and has a lot of good information on what to try and what to experiment with. Another performance tuning attribute is the executor threads. The default is 250. Adjust this value to increase the number of threads used to execute proposals. This is write activity. If you see that your write activity is very heavy and you feel that the proposals aren't being executed fast enough, this might be an attribute to increase. The decoupler pool size default is as 100. The number of proposals the coordination can handle in parallel. This is what this attribute affects. And then finally, the transfer chunk size. The default is 4096 kilobytes. And this is the chunk size that the IHCs transfer content to remote Fusion servers. And remember, the IHC is the inter-Hadoop connector, and that's really the reader. For very large file sizes, this modification can improve performance a bit. 32768 is common. Like with all performance tuning, the recommendation would be to read the guide first and then make changes to these attributes one at a time, because it'll be hard to determine, or very difficult to determine anyway, what change has affected what if you do them all at one time. Memory considerations. Like any Java virtual machine, you need to tune heap to accommodate growing demands. And this is with HDFS and with object stores. Actual memory utilization is bounded by configuration variables such as the agreement store segment size, the default 10,000. Anything beyond this starts spilling over to disk. So it's important to tune the heap to fit the configured values. Edit the etc WANdisco Fusion server fusion_environment.sh file, or use the Fusion UI. The IHCs generally have a much lower heap requirement. 8 or 16 gigs should suffice for all but the very largest environments. And what we're seeing and what we've experienced most is that for the Fusion server, 16 gigabytes is a good heap size to start with, and with the IHC, 16 is fine. I have seen situations where for object storage replication using Live S3, you might want to set the Fusion server heap higher, but still leave the IHC at 16 gigabytes. And for HDFS, 16 gigabytes should be a good starting place. Large data volume considerations. Segment replication loads into multiple rules. And the idea here is you don't try to replicate long trees, long HDFS trees, and start at the root. That's a recipe for a lot of agreements and a lot of data being transferred. For large volume transaction counts, scale up CPU, heap, and thread tunables to handle the point-in-time workload. The Decon coordination engine has a small transaction database. It's not large at all, and we would recommend putting this on solid-state disks to avoid I/O bottlenecks. If at all possible, request solid-state disks for this Fusion server where your transaction database is being stored. For large data volumes, also consider WAN acceleration products. BridgeWorks is a partnership of WANdisco, and this compresses data, which is transparent to Fusion. Now, it does compress data, but we would consider this only for certain type of workloads. For example, a workload that transfers many small files in the mix with a few large files, very large files, BridgeWorks might not be as effective. But if you have a medium or small number of very large files, this BridgeWorks compression could be very effective in improving performance. Small cluster problems. You're usually going to see small cluster problems, and what we call a small cluster is any Hadoop cluster with fewer than 10 nodes. This can be prone to right-line pipe failures under heavy loads. You'll see this in a testing environment or maybe a POC environment, and this is usually when those environments are pushed past what they should be used for. This is because if a data node is unresponsive, the name node servicing that data node will issue a write pipeline failure due to the inability to meet block replication requirements. For example, the standard block replication factor is 3 on most clusters, and it might not be able to replicate 3 copies of that block. And with fewer data nodes available, each data node is hit proportionally harder. It's very easy to overload those 3-node clusters when you have a replication factor of 3. So this can be tuned down, especially if it's a testing or POC environment. The block replication can be set to 1 or 2. and that might help alleviate some of these problems. The HDFS configuration can be changed to address this, but be aware that most POCs and demo sites are small clusters, and I wouldn't push those environments very heavily. So very much scope your POC. Try to transfer files that are large enough to prove what Fusion can do, and try to scope it so you're not sending too many files or replicating too many files or too many directories, just to prove the concept that Fusion will keep those clusters consistent. That's the best rule of thumb to use, and not to try to overload it, or you will run into these problems mentioned on this slide. Fusion now defaults to the best effort configuration for the block writes. But as stated before, with small clusters, just remember they are small, and with POCs or test environments, don't push them too hard. Just use them to prove that Fusion keeps those clusters consistent. Consistency check and repair performance. Consistency check and repair replicates existing data. This is where you run the consistency check and it says this is where the two clusters are not in sync. In the repair, using one of them as the source of the truth, we'll copy that data to make it consistent. This could include huge data sets for migration and upgrades, and that could be multiple petabytes, millions of objects. So be real careful if you're using the consistency check and repair for a migration. If you're, for example, migrating 50 terabytes of data, that could take a long time. It could take a day or two. Repair threads are included in the executor threads total settings. Repair threads default to 50. This specifies the upper limit of threads to dedicate to repair operations. The repair thread limit default 25 specifies the max number of files that can be scheduled by any individual repair at a given time. This helps prevent large repairs from hogging the repair threads. It gives small repairs a chance to work, to operate. If you only run one repair, still, that's 25 threads, only 25 threads, many small files, more parallelization. That's the key here. We can't stress enough that using consistency check and repair for migrations, you must consider how much data you're moving in that repair operation. Sizes of many terabytes, meaning 10, 15, over 100 terabytes is just going to take a long time. OS and network tuning. Ensure your Java version is up to date and has no performance issues, and these can be searched through any online search engine. Most tunings that would benefit a name node or a large web server should also benefit Fusion, and this includes some of the following attributes like the swappiness size, disabling transparent huge pages, some network kernel tunings, and some network kernel tunings for high client connection rates. As you could see here on the slide, these can all be effective in tuning operating system and network performance issues for Fusion. Best practices. Increase the granularity of replication level. That means if you have more replication rules, you have more threads. Never really try to avoid replicating root folders. That's just too large. Just the replication rules you need and that the client or the customer requires for implementation is the best practice. On HDFS, on the Hadoop file system, exclude data that isn't needed, what we call transient data. Those can be excluded in rules, and that will avoid unnecessary load. These will be temporary files that really have no importance in your overall replication strategy. Your Fusion replication environment can be load balanced by adding more Fusion servers to each node. In this case, each rule is assigned a writer. Rules are load balanced, and each destination Fusion server can receive data from multiple IHC servers, those inter-Hadoop connector reader servers. And more IHC servers means more concurrent transfers. One rule of thumb, though, and one best practice that's starting to emerge is never add more, or try to avoid adding more than 3 Fusion servers per zone. Adding more than that will just put more stress on the decone agreement and consensus algorithm, and it might just add more traffic than is necessary and affect performance. So rule of thumb is limit it to 3 if you can, and that should be performant enough. And finally, bandwidth limits can be throttled between clusters. I would recommend testing this first in an environment that you have full control over. Maybe create some larger files, 90 gig or so, and send them over and throttle the bandwidth limits to, let's say, 5 meg, and see how the data transfers go, and then throttle them back to 0, meaning full bandwidth, and just see the difference. This concludes the WANdisco Fusion lesson on performance tuning.